So we will do the second example. Alright, let us look at the second example. It is similar to the one we just did. So what it says is find the length and width of a rectangle. Let us make a rectangle there. You want to find out the length and width. Let's say length is x and width is y. You can assume L and W. That's perfectly fine. What it says is the area is 36 square feet. And the perimeter is minimum. So we need to know the formula for area and the perimeter. Okay, if this is x, that will be x as well, right? If this is y, this will be y as well, right? So what it says is area is 36. So you can write x times y equals to 36. We assume the length is x and the width is y. That's what we are assuming here, right? So x times y is 36, it is given. And then what it says is perimeter. What is the formula for the perimeter? Perimeter is basically the sum of the sides, right? So it is x plus y plus x plus y. So that will be 2x plus 2y. So 2x plus 2y. Again, you want to minimize the function p, like we were minimizing the function s here, right? So how do you do that? Is solve the first one for y, 36 over x, and plug in that here. So p is basically 2x plus 2 times 36 over x. You see that? So what you get is basically 2x plus 72 over x. Okay, so again same steps. Find out the p prime. That is 2 minus 72 over x squared. Why is that? Why the derivative is negative here? Because 72 times, you can write 72 times 1 over x, right? So similar to the previous one, 1 over x is x to the negative 1, and if you find the derivative, you will get if you find the derivative of that, you will get negative 1 x to the negative 2, right? And negative 1 over x squared. That makes negative 72 over x squared. And to find out the critical value, what you do, you set that equals to 0, right? If you set that equals to 0, you will get 2 minus 72 over x squared equals to 0, right? Now add this to both sides. You will get 2 equals to 72 over x squared. Multiply by x squared on both sides. What do you get? Is 2x squared equals to 72, right? You cancel this and that. So divide by 2 will give you x squared equals to 36. So what is x? X will be either positive 6 or negative 6, but x is the length, so it cannot be negative, right? So x is 6. What will be y though? So therefore y will be 36 over 6 from here, right? And plug in that will be 6 as well. So you got x equals to 6 and y equals to 6. But still we are not done, because it says we need to find this x and y value makes the perimeter minimum. So how do I check whether it is minimum or maximum? You find out the second derivative, right? If you do the second derivative, what do you get? Second derivative will be you find out the second derivative here, right? Here. So 0, the derivative of 2 is 0 minus 72 times, what is the derivative of 1 over x squared? It is like x to the negative 2 derivative of that, right? So what you get is basically p double prime equals to negative 72 times negative 2 times x to the negative 3, right? So basically it gives you 144 divided by x to the cube, right? Now we want to check whether at x equals to 6 the perimeter is maximum or minimum. What is the value of p double prime? That will be 144 divided by 6 to the third. 36 times 6 is 216, I think, right? So 36 times 6. Yes. So how much is that? 144 divided by 216 is equals to 0.66. So 0.66, right? So that means therefore hence P is minimum at x equals to 6. That's what we got, which is the complete solution of this problem. Okay, let us do another example. A farmer wishes to fence a rectangular field where the fourth side is a river and will not need fence. If the area to be covered is 405,000 square meter, find the dimensions so that he needs least amount of fencing. Meaning that he want to fence the given area with least amount of fencing, right? Let us suppose that this is x, so this will be x, this is y, that will be y, but you don't need fencing because there is a river on that side. Okay, so let's say the length is x and width is y. Then what it says is the area to be covered is 405,000. That means x times the y equals to 405,000, and what he needs to minimize is the sum of the length and width, right? That will be the, let's say the p is equals to again 2x plus just y, because he doesn't need fencing, and that he wants to use the minimum of the fencing wire. Okay, that's what we want to minimize this one. As before, you solve the first one, you get y equals to 405,000 divided by x, right? So what you do is you plug in there 2x plus 405,000 divided by x. Now you want to find out the derivative again, exactly the same procedure. 2 minus 405,000, this is 405,000 divided by x squared. Again, how? Because you need to move this to the top and then x to the negative, so you will have 405,000 times x to the negative 1, and then you find out the prime of that, right? So what will become is negative 1 x to the negative 2, that is negative 1 over x squared. That's how I got plus changed to minus there, right? So to find out the critical numbers, what you do, set p prime equals to 0. This implies 2 equals to exactly the same process, okay, divide by x squared. Now multiply both sides by x squared, you cancel that, and then you will get x squared here, right? So what you get is x squared equals to 405,000 divided by 2. So what do you get? 20, 25, 20, 20, 25, 0, 0. That's what you get. So if you take the square root, so this implies x equals to 450. That's what you got for x. So what will be y then? Then this is x value, right? And then the y value will be, how much is that? 405,000 divided by x is 450. This will give you 900. Okay, but again we are not done, right? Although we find out x and y, that is basically y. Although we find out x and y, we need to check whether this will minimize the perimeter, okay, perimeter of the three sides. So to do that, you need to find out the double prime of p, right? So what will be the p double prime then? So you find out the derivative of this one, so it will be 0 minus 405,000 times, how much is the derivative of 1 over x squared? You need to move this to the top, right? And then do x to the negative 2 prime. That will be negative 2 over x to the third. Exactly the same way that we did before. So this will give you, how much would that be? It will be 405,000 times negative 405,000 times negative 2 will be, how much would that be? That would be 810,000. 810,000 divided by x to the third, right? So at x equals to 45 500, we will get P double prime will be 810,000 divided by 450 to the third, which will give you positive number, right? Because I don't know how much is that, and you don't need to know that too. So this is positive. That's the only sign that we are interested to. Hence the perimeter P is minimum when the x or the width is 450 and then y is basically 450. What do we get? Y is 900. That's the end of this solution.